All right, guys, we're going to keep talking about radicals today. This is radicals part 2. And let's start off by saying, let's say you look in the worksheet today and you see a problem that says the cube root of 16. And you think to yourself, okay, so I'm looking for a number where if I multiply it by itself 3 times, the answer will be 16. So you start with 2, and you say, okay, well, 2 times 2 times 2 is 8, so that's not the answer. And then maybe you try 3. You say 3 times 3 times 3 is 27, that's too big. So what we notice here is there isn't a whole number answer to this question. There is no whole number where if you multiply it by itself 3 times you end up with 16. Now what that means is we can't evaluate. We say evaluate when it means find the answer. What we can do instead is we can simplify it, and that's what we want to focus on for part 2. So I want you guys to notice that 16 is 2 times 2 times 2 times another 2. It's actually 2 to the 4th power. Now, the first 3 2's in there, these 3 right here, or I'm going to say the first. It really could be any 3 of the 2's. But let's say those first 3 2's there are a perfect cube, and that part can be simplified. Well, what's going to happen is after you do that, there's going to be one left over here. And that one stays in the radical. So I'm going to talk about simplifying. Here's a quick vocab term. When you're doing a radical and you have that number in front, that small number in front, that's called the index of the radical. And that's important because when you're simplifying radicals, whatever that number is, whatever that index is, you're always looking for groups of that many. So the example I just gave you was a cube root. That's why we could take 3 2's out. If the example was a 5th root, I could take 5 2's out. If it was a 10th root, I could take 10 2's out. Whatever that index is, that's what you're looking for. You're looking for groups of that many. So let's simplify the cube root of 64. And what I'm going to do in order to answer this question, I want to break it down using what we call a factor tree. So I'm going to take the 64 and I'm going to start breaking it down. I'm going to say, first of all, let me just start with 8 times 8. 64 is 8 times 8. And then I say, well, each of those 8's can be broken down too, because each of those is 4 times 2. Now, the 2's are done. You can't break a 2 down anymore. We don't want to use 1's on factor trees. But each of these 4's can be broken down one more time into 2 times 2. So if you look at what's left over on the bottom of your tree, we actually have a whole bunch of 2's here. We have 1, 2, 3, 4, 5, 6 2's. So that means that 64 is 2 times 2 times 2 times 2 times 2 times 2. 6 of them total. Now once you realize that, the next step is I look at the index variable and I say I'm taking a 4th root. That means I can take groups of 4. So these 4 2's I can simplify, bring out front, and it turns into 1 2, just 1. So I'm going to take that 2 out front. I'm going to leave the 4th root. And what's inside of it is what's left over, 2 times 2, which is 4. So my simplified answer would be 2, the number 2, the whole number, times the 4th root of 4. So that's how simplifying radicals works. You want to start with that factor tree and break down the number as much as you can. Once you've broken it down, you want to look at the index variable and look for groups of that many. If there are any groups of that many of the same number, you can take those out of the radical. Every group that you take out becomes one of those numbers out front. So that's why the 4 2's that I circled in red became 1 2 out front. All right. Now this process also works with variables. And what's good, it's kind of unusual, it's actually easier with variables because you don't have to worry about the factor tree. So a lot of times in math, we learn something with numbers and it's easy, and then we do variables and it's harder. This is actually backwards. We learned it with numbers, and we had to do that factor tree, which is a little bit tricky. With variables, it's actually much easier. So here's an example of that. Let's say we want to simplify the 5th root of x to the 8th. And this is why I said the question's actually easier. I don't even need a factor tree. I know that x to the 8th is 1, 2, 3, 4, 5, 6, 7, 8 x's, because that's what x to the 8th means. And then I'm going to count up 1, 2, 3, 4, 5 of them. Pull that out front. So that gives me 1 x out front. And then what's left over on the inside, just count them up. 1, 2, 3 x's. That would be x to the 3rd power. And that's my answer, is x times the 5th root of x cubed. Now I want to do one more example with you guys, because I want you to see one where we put it all together. We have the number, and we actually have 2 different variables in there. So because we have the number, let's start off with the factor tree again, like we did in our first example. So let's take the 50, and let's split it up. So when I see that 50, I think, okay, well, let's start off with 5 times 10. The 5's done. It can't be divided anymore, but the 10 could be 5 times 2. So the 50 is going to be 5 times 5 times 2. So we have 5 times 5 times 2. And then the rest of it is easy. We don't need factor trees. We need 7 x's. 1, 2, 3, 4, 5, 6, 7. And then we need 3 y's. 1, 2, 3. Now, one thing that's interesting here, there is no index. This is actually a square root. If there's no number there, if there's no index there, it's a square root. And remember, even though you don't see it, a square root actually means 2. So what we're looking for is groups of 2. And if I look, I have 2 5's. I only have 1 2. I can't take that out. I have 2 x's here. And then I also have 2 x's here. And then I have 2 more x's here. So you can have more than one group of the same number or variable. And then I have 2 y's right here. So if I take out 1 5, 1 x, another x, another x, and a y, what's left over is the 2, 1 x, and 1 y. Now all I want to do to finish simplifying my answers is let's combine these. So for my final answer to the question, I'm going to say 5 x to the 3rd y times the square root of 2xy. So that's what we're doing today for part 2. Instead of evaluating or getting an exact answer for a radical, we are simplifying them as much as we can. Remember, it has to do with breaking down numbers. You can use a factor tree. And then looking for groups of whatever your index is and factoring those out.